Hello, so I'm going to explain question 2 of MEXT Physics Undergraduate 2015. So let's go to number 1. So the problem is that there is a conducting bar of mass m that can slide without friction on a pair of conducting rails separated by a distance d, located on an inclined plane that makes an angle theta with respect to ground. The two rails are connected by a resistor. The resistance of the resistor is noted as R. A uniform magnetic field of magnitude B is directed upward, perpendicular to the ground, over the entire region through which the bar moves. The bar is released from rest and slides down. So it moves from rest and slides down. The acceleration due to gravity is denoted as g. So number 1 is which way does the current flow from A to B or B to A? And the theory that you have to know is that the force that is caused by this magnetic reaction is L, the length of the bar, times the cross product of I and B. And to find the direction of F, we can use the right hand rule. So you can use the method of this image, but there is an easier way. So, and the key is the order of the cross product. So the first one, that is I, move your palm of your move the palm of your hand from I to B and see the direction of your thumb, and the direction of your thumb is the force that is the result of the cross product. So the trick is that the first one, move your palm of your hand from the first one to the second one, and the direction of your thumb is the direction of the result of the cross product. So to solve this problem, when you read the questions after, you'd know that the force of the magnetic is directed towards the left. So to find I, let's put your thumb towards here and move your palm of your hand, and the palm of your hand will move like this. Can only move like this. So the I that is possible from here is the direction from B to A. So the answer is B. Number 2. Now the bar is moving along the rails at speed v. The bar is always perpendicular to the rails. Number 2. Which of the following is the correct formula for the induced current I? So what you have to know is that when there is a conducting rails and a conducting bar moves, when there is also a magnetic field, it induces a current or voltage towards this electric circuit. And to express that induced voltage, that is M, is equal to the cross product of V and B times L times the length of the bar. And you should know that the voltage over resistance over the resistor is equal to the current. So the current is equal to voltage over R. And you should also know that the horizontal component of a vector, or the adjacent component of a vector, is phi cosine theta, and the opposite component is phi sine theta. So we can use this equation this mth equation, that is cross product of phi b times the distance of the length of the bar, that is d. So we substitute L as d, and the meaning of a cross product is that the two factors have to be perpendicular to each other. So from the problem, we know that the b is perpendicular to this line, and to search the b that is perpendicular to the line of this inclined plane, that is also the line that is in the direction of phi. So the direction of phi is along the inclined plane, and the b is the b have to be perpendicular to phi, that is that is the direction of the inclined plane. To find the b here is we have to know this angle. So assume that we don't know this angle, so let's say that this angle is alpha. So the sum of a triangle of the angles of the triangle is 180 degrees, and we know that this angle is 90 degrees. So alpha plus something that is theta plus something that is alpha is 90 degrees, and we know that this angle is also 90 degrees, and we know and alpha plus something that is alpha plus something is 90 degrees. So we know that that angle is theta, and the angle here is just the reflection of this angle here. So this angle here and this angle here is the same. So we know that this angle is theta. So this vector is adjacent to the to theta. So we know that b here, this vector here, is b cosine theta. So we can write the cross product of phi and b as phi b cosine theta. So we also know that the induced current I is just the mth over r, so we can divide off this by r. So the answer is phi dB cosine theta over r, that is f. Number 3. Besides gravity, the magnetic force acts on the bar. Find the correct formula for the component of this magnetic force along the inclined plane. So we knew before that the F magnetic is the length of the bar times the cross product of I and B, and we know that the length of the bar is D and the cross product of I and B, and we should search the cross product of I and B. And to remove the cross product, just like before, the vector of I and B have to be perpendicular to each other. So since I is along the inclined plane and B is perpendicular to the ground here, we should use the B that is perpendicular to the inclined plane, and we know that the B that is perpendicular to the inclined plane is b cosine theta. So we can write the cross product of I and B as dib cosine theta. And we know from the problem before that I is equal to phi dB cosine theta r over r, so we can substitute that to here, and we get phi d squared b squared cosine squared theta over r, that is c. Number 4. After a sufficiently long time, the bar moves at a constant speed. At this terminal velocity u, the gravity force is balanced by the magnetic force along the inclined plane. Find the correct formula for u. So there is, a force, the gravitational force, that is mg, from the block to the ground, so it is vertical. And the gravity is affecting the block, so there is also the component of mg, that is this vector that is along the inclined plane. So we have to know this vector. So to find this vector, we know that this is alpha, and we know that this is 90 degrees, so alpha plus theta is 90 degrees. So this vector is the opposite of theta, so we know that this vector is mg sine theta. So we know that F magnetic is mg sine theta. And we know from before is that we know from the question before is this equation, and we can substitute F magnetic from this equation, and we can replace phi as u, since this is in the case of the terminal velocity u. So we can write this in equal to u, so r moves here and this whole thing moves to the bottom, so the answer is mgr sine theta over d squared b squared cosine squared theta. That is answer E. Number 5. Which of the following is the correct formula for the rate of work done by gravity on the bar? So what you have to know is that the rate of work is, that is P, is equal to the work over time, and the work done by gravity is just another way of saying the potential energy, that is mgh. So we can write the rate of work as mgh over t, and we can see h over t as the distance traveled vertically by the block over time, and we can express that as the vertical component as of u. So h over t is equal to this vertical component of u, that is u sine theta. So we can write h over t as u sine theta, so the p is equal to mgu sine theta. And from the problem before, we know that u is equal to this, and we can substitute u as this, and we get m squared g squared or r sine squared theta over d squared b squared cosine squared theta. And we can see sine over cosine, and sine over cosine is just tangent, so we can write sine squared theta over cosine squared theta as tangent squared theta. So the answer is m squared g squared r times tangent squared theta over d squared b squared, that is E.